Today our lesson is conservation of energy. Okay, so let us first begin with the statement of the principle of conservation of energy. Principle of conservation of energy states that energy can neither be created nor can be destroyed, but it can be transformed from one form to another. Okay, there are plenty of examples in which energy is transformed from one form to another. For example, while rubbing our hands, mechanical energy is transformed into heat energy. Okay, during photosynthesis, light energy, or you can also say solar energy, gets transformed into the food, which is a chemical energy. There are plenty more examples in this matter, but we'll go to our lesson. We'll stick to our lesson today, and our main lesson for today is conservation of mechanical energy for a freely feeling body under the action of gravity. In simple words, we can say whenever a body is falling from a certain height, the total energy is always constant. The total energy, in a sense, total mechanical energy is always constant. Or here we have to show that when a body falls freely under the action of gravity, the kinetic energy and potential energy, the sum of kinetic energy and potential energy is always same. We have to show that. Okay, we have to show that when a body is falling freely, at each and every point we have to show that the total energy is always same. Okay, let's begin now. Out here we can see there are 3 points A, B and C. We have taken only 3 points for our consideration in this numerical, or in this derivation to be precise. Okay, let's begin. Let us consider a body of mass m be falling freely from a height h above the ground under the action of gravity. So at this point the body is at A, mass of the body is m, and the acceleration due to gravity is g. Okay, now the height of the body from C to A is h. C is a ground level, B is some point, and A is the top position. Okay, and at the beginning the body is at A, which means the body has the velocity 0 when it is at A, because the body is not falling yet. Okay, now at A, u is 0, which means initial velocity is 0. Okay, because the body is not falling. Height is h, C is the ground level, and the body is at the maximum height. The body is at h. Mass is already said, it is m. Now K is 0. What is K? K is the kinetic energy. We have already discussed in our previous lesson that kinetic energy is the energy when the body is in motion. At A, the body is not at motion because it is at rest. U is 0. Therefore, kinetic energy is 0. Alright. Now, what about potential energy U? In this case, the potential energy is gravitational potential energy. And we have already discussed the formula for gravitational potential energy is mgh, where h is the height above the ground level. Out here, what is the height above the ground level? It is h. So the potential energy becomes mgh. Now what is total mechanical energy? Total mechanical energy at A is sum of kinetic energy and potential energy. Since kinetic energy is 0, the total energy at A becomes mgh. Alright. Now at B is some point in the middle of the path. Now the body is falling down and it has reached B. When the body reaches B, you can see it has already covered the distance x. Look at the diagram. When the body has reached B, it has already covered the distance x. Right? So, okay, the body has already covered the distance x. And what is the remaining height now? The remaining height is h minus x, because the total height is h and x has already been covered. Therefore, the remaining one is h minus x. Now, u is 0 because at A initial velocity is 0. V is Vb. Now, what is this V? V is the velocity at this point. At this point, we have considered the velocity to be vb. Okay, and s is h minus x. What is s? S is the height of the ground. At b, height of the ground is h minus x, and a is g, which means acceleration due to gravity is g. Okay, now we want to know what is the velocity at this point. I have already said out here, velocity at this point is v is vb, but we want to know what is this vb. To know the exact value of this vb, we take the help of equation of motion which we have already learned in class 9. There are three equations of motion which we have learned in class 9, and this is the one among them. Okay, v square equals to u square plus 2as, where v is the final velocity. Out here v is vb. Okay, v is vb at this point b. U is 0, initial velocity 0, because initial velocity means velocity at a, which is 0. To a is the acceleration due to gravity, and I have already said s is the height at that point. At that point the height is h minus x. Don't get confused with this x. This x is the distance traveled or covered by the body to reach b. X is the distance covered by the body to reach b. Okay, now the body has reached b by traveling distance x, but what about the height at b? The height at b will be h minus x. Okay, now from here vb square equals to 0, because initial velocity is 0, to a x, because the out here there is a little confusion. Don't get confused out here. I have written s out here. S is the distance covered by a body. Okay, this is the height. Capital S is the height. This capital S is the height, which is h minus x out here, and this small s is the distance covered by a body to reach this point, which in our case it is x. So vb will become 2gx. Okay, if you are confused out here, you can write down in the comment. I'll try to explain at that time. Okay, now I want to know the kinetic energy at this point. What will be the kinetic energy at b? The formula for kinetic energy is half mv square. V is vb out here, we already know that. Now out here half is half, m will be m, vb square. In place of vb square, what will write down? 2gx. So these 2 and 2 of the half gets cancelled, the remaining one is mgx. So the kinetic energy will become mgx for us now. Okay, now what about potential energy? Potential energy is mgh. Okay, out here I have written s, capital S, because I have considered this to be the height at b. So mg, in place of x I have to write down h minus x, because this is the height at b. This is the height at b. So while finding the potential energy for b, we need to consider this height, particular height, which is h minus x. That's why I have written mg h minus x. Okay, expand this, open this bracket, it becomes mgh minus mgx. Okay, now next we have total mechanical energy is kinetic energy plus potential energy. Kinetic energy is mgx, potential energy is mgh minus mgx. So this mgx and this mgx gets cancelled, so what is remaining? Mgh. Alright, now we will go to the point C. At C, let's check what is out there. Initial velocity is 0, final velocity v is vc. When the body reaches c, its velocity becomes vc. We have considered that. S is h. So how much distance the body has covered to reach c from a? Body has covered the distance h. Okay, from a to c, when the body falls down from a to c, it has already covered the distance h. Alright, a is g, we know that. And again we have considered the equation of motion, v square equals to u square plus 2as. So v becomes vc, u is 0, we already know that. 2a s becomes h, because the body has already covered the distance h. So Vc square becomes 2gh. Now again I want to know the kinetic energy at point C. What is the kinetic energy of the body at point C? It is half mv square. Half is half already. M is the mass. Vc square, we put this value 2gh. So half m 2gh, 2 and half gets cancelled. So what is the remaining one? Mg. It's the remaining one is mgh. Okay. So the kinetic energy at this point we have got mgh. Now what is potential energy? Potential energy is 0. Now why is this potential energy 0? Because we already know the formula for potential energy is mgh. And what is the height at C? Height at C is 0. So automatically m into g into 0 will become 0. That's why the potential energy at C is 0, because height is 0. So the total energy is kinetic energy plus potential energy, which is mgh plus 0, which is mgh. Now if you see properly out here, at A also mgh total energy, at B also total energy mgh, at C also total energy mgh. So from all this we can come into one conclusion, which is the total mechanical energy for a freely falling body is constant. Okay, the total mechanical energy is same always when a body falls freely under the action of gravity. Okay, now this is one important section. After we have to learn the graph in which there is a comparison, or it shows the increase or decrease in kinetic energy, potential energy and total energy. How does the energy change with the increase in height? Okay, now we have taken energy along positive y-axis, we have taken height along positive x-axis. Now what is the formula for potential energy? Mgh. Formula for potential energy is mgh, which means when the height increases, the potential energy increases. Now look at this, the height is increasing along x-axis, and with the increase in height, potential energy is also increasing continuously. Okay, again, if you throw a body up in the sky, will it go up forever? Will it go up forever? No, it cannot go up forever when a body is thrown above the against the gravity. When we throw, a body will move up and the velocity will continuously decrease, and when it reaches a certain point, it cannot go further up. It cannot go further up, and from there it will fall down. So at this point, the body cannot go further up because the velocity is 0 out here. The velocity is minimum out here. Okay, when the body is thrown up, it reaches the point from where it cannot go up. At that point, the velocity is minimum. So from here, what can we understand? We can understand when the height increases, the velocity decreases. Okay, and it becomes 0 at the maximum point. When the height increases, the velocity decreases, and when the velocity decreases, kinetic energy also decreases. So what we can understand from here? From here we can understand when the height increases, kinetic energy decreases. This is what is shown in this graph. Look at this. In this graph, when the height increases, kinetic energy is decreasing, and at the maximum height, the kinetic energy is becoming 0, because this is a 0 level. At maximum height, the kinetic energy is becoming 0. Okay, now this graph is for total energy, total mechanical energy, and it is a straight line out here. Why it is a straight line? Because total mechanical energy is always constant. The sum of kinetic energy and potential energy is always constant. That's why it is a straight line. Okay, now next we'll move to the simple pendulum. Okay, we can see simple pendulum out here. This is a simple pendulum. We already know what is simple pendulum, isn't it? Now when this pendulum is oscillating, okay, we have to keep in mind 3 points. The maximum point, these two are extreme points, and this is the middle portion or mean position. Okay, you can see here the pendulum cannot cross these marks. Why pendulum cannot cross these marks? Because at these marks the velocity becomes 0. the velocity becomes 0, that's why it cannot cross this marks. Now look at this portion out here, look at this, check this, that is the maximum point, that's why the v is given as 0. The velocity is 0 but the height is maximum, isn't it? At that point the pendulum has maximum height because it goes like this. Look at this, small height, and the pendulum height increases, and at this point the height becomes maximum. When the height becomes maximum, what becomes maximum? Potential energy. Okay, when the height becomes maximum, what becomes maximum? Potential energy. Look at this, check at this point. Maximum potential energy, no kinetic energy. Why no kinetic energy? Because the velocity is 0. Why only maximum potential energy? Because the height is maximum. I hope you are understanding this. Same goes for this position also. Maximum height, so only potential energy. Or there also only potential energy because maximum height. Okay, let me draw this first. Now what happens in this mean position? Maximum kinetic energy. Why maximum kinetic energy? Because the velocity is maximum at this point. Okay, velocity is maximum, that's why maximum kinetic energy. Order is given, center position, only kinetic energy. Now what are we doing in this pendulum? What actually we are learning in this pendulum? Actually we are learning, look at this, principle of conservation of energy in simple pendulum. We want to learn how does the principle of conservation of energy follows in this simple pendulum. Okay, now I'll explain you. When the pendulum reaches maximum height, its velocity is 0. Velocity 0 means kinetic energy 0. Okay, no kinetic energy, it's given out here. Why no kinetic energy? Because velocity is 0. Same case for here also. In extreme position, no kinetic energy because the velocity is 0. It cannot go further. Why velocity 0? Because it cannot go further. Look at this. The pendulum cannot cross this line because the velocity is 0 at that point. Okay, this line. Alright, now what happens at this point? At this point the velocity becomes maximum, that's why the kinetic energy is maximum. At this point the kinetic energy is maximum because the velocity is maximum. Now what about the potential energy at this point? The potential energy is 0, but look at this, the height is 0 at this point. Look at this, at this point the height is 0. When it goes up, then only height increases like this. When it goes up, then only height increases, but at this point the height is 0. At this point the height is 0, that's why the potential energy is 0 at this point, and it has only kinetic energy at this point. Now the main question is, how can you explain the principle of conservation of energy in simple pendulum? Listen to this answer carefully. How does principle of conservation of energy takes place in simple pendulum? Alright. Now when the body is in mean position, the velocity is maximum. Okay, and when it tries to goes up, the height increases but the velocity decreases. Okay, when the height increases, what increases? Potential energy increases. Okay, when the height increases, potential energy increases, and when it reaches this extreme position, it will have maximum potential energy, but the kinetic energy becomes 0 at this point. At this point the potential energy is maximum but the kinetic energy is 0. Now what can we learn from here? We can learn, when the body is going up, its kinetic energy gets converted into potential energy. Okay, again now reverse happens. Now the pendulum starts falling down from here. When the pendulum falls, at this point the kinetic energy is 0. At this point the kinetic energy is maximum. Why is this so? Because when the body falls down like this, when it swings back in this direction, when the pendulum swings back in this direction, the height decreases, that's why the potential energy decreases, but the velocity increases and becomes maximum out here. So all the potential energy gets converted into kinetic energy. Again same follows in this case. So when the body is at extreme position, it has potential energy, and when it goes to towards the mean position, its potential energy gets converted into kinetic energy. In this way, the total mechanical energy gets conserved in simple pendulum.